Hello and welcome to YMT217 Programming Languages. Today we'll discuss the first part of Chapter 1, which actually will discuss the preliminaries or the elementary thoughts about the chapter itself. So in today's session we will discuss two main topics. Actually they are not short, but we will just discuss these two. We will restrict it to these two so that we shorten the video time. So we'll discuss the reasons for studying the concepts of programming languages. Why do we need to study such a course? And why do we need to even care about studying it? And also we will discuss programming languages, the language domain or the programming domains, the domains for which we use programming languages. So let's go ahead and discuss those one by one. Why would we actually study the concept of programming languages? Let's say you as a student of software engineering or also computer engineering or any relevant field where programming is necessary, you may say, why would I study a course called Concepts of Programming Languages or Programming Languages in general? Why do I need to study this course? I already know, let's say, multiple programming languages. I know them, so I can program with them. Do I need to learn the concepts? For sure, the answer is yes. So in that case, we will just justify for what we are studying such a course. Now, let's just take the first suggested reason. By the way, these reasons we list here are not all the possible reasons, but they are the most important ones. For sure, they are the most important ones. And once we discuss them, you will have a better idea about why we are studying such a concept. Increased ability to express ideas. Now think about it. Not only in programming languages, in also languages themselves. Imagine if you have more than 2 or 3 languages that you speak with, you communicate with. For sure, the way you would express yourself would be much better than if you have only your own native tongue or just 2 languages. And there are a lot of studies about this actually. Once I have come across with one of these studies where it was actually done to primary school students, those who had one language, how they were thinking of math and how they were expressing their ideas, and others who had 2 languages and others who had 3 languages or more. So the outcome of the study indicated that those who had 2 languages knew better ways for solving math problems and expressing their ideas in a more clear way than the ones who had only their native mother tongue. Plus, one more thing, they found also that those who had that time 3 or more languages could express themselves in a unique way compared to others. So now think about the idea, unique way. That means you will be able to express your ideas as an engineer or a programmer in a unique way the more you have programming languages understanding or concepts in your mind. Okay, so this is the basic idea. Knowing 1 or 2, a couple of languages, that will not help you actually to master all needed features and basics for creating efficient programs or writing efficient software packages. So that's why a knowledge of one language is not enough. A knowledge of many is good, but through what? Through actually the concept of programming languages. So you learn the concepts first before you go and master the language, and I'll explain why. So basically, as I said earlier, the idea of having limited number of programming languages for a programmer limits also the ability of these programmers in producing efficient software and efficient programs, and that is one of the reasons. Another reason if you are aware of how actually a computer, of course, computer programming language is created and what kind of constructs, that means the basic compositions of its instructions and you can say functions or routines and etc., then how you will think about that language. You will be encouraged to use it when it is necessary. So you know the details of certain languages, constructs, how it is used, and in which fields it's actually more applicable, then you know which language you will go for. And that's exactly actually with many students who are, you can say, talented in different types of languages. When we give an idea, they say directly, okay, we can use that language for this application, or we can use this language for this kind of project. This is exactly the idea. Increase the ability to express your ideas. You know about the restrictions, the data structures, the control structures, whatever related to the abstraction. If object-oriented the language is or structured, you know its limitations, you know its abilities, when it is efficient, when it is inefficient, so you know how to apply it in a good way. Okay. Improved background of choosing the appropriate language. It's directly related to expressing your ideas, but in this case, actually, the idea is a bit more advanced. How? Now imagine you study software engineering and you finish your course, you finish your you finish your study, not semester, you finish your study, the whole study, you take your certificate. Let's say throughout your study you learn, let's say, 5 languages, let's say, and you never develop yourself. Look, technology is changing quickly and new programming languages come to existence more frequently these days. So what happens? If you rely on the knowledge you have from your bachelor degree time, after 5 or 10 years, you will find yourself actually not up to date. You will find yourself outdated, and you will force yourself to use a knowledge which does not fit your context, your environment, and that's a problem. That's for sure a problem. So in that case, if you are going to choose a language, you will have a limited choice of languages. Let's say you have 5 languages, but maybe outdated. Not all of them, but one or two of them maybe can be compatible, but the rest would be outdated. And that's a big problem for you to properly address the problem of which you are trying to solve. So you need to have a good background about the appropriate language that fits the project in hand. And what you need to do is, actually, you need to have certain characteristics for choosing. Characteristics means what? How the language will be if I apply it to this. How about the constructs? Are they fit? How about the data structures? How about the control structures? Will we use programming language X over Y? How about if we use it? Will be the outcome efficient or inefficient? And that's exactly the case we speak about here. Increase the ability to learn new languages. For sure, this applies also to the languages we communicate with. The more languages you learn, the easier it will be to actually accommodate for a new language. Now let me explain it in another basic sense. Think about it. If you know one structured programming, let's say like C, it's easier for you or easy for you to learn another structured programming. Why? Because you understand the concept already. So you have no problem with absorbing or understanding or actually comprehending a new language from the same category. If you know Java, and I know you guys studied Java, which is an object-oriented, it's not hard for you to learn another object-oriented programming, let's say C# or maybe Python or from any other family of object-oriented. Why? The concept more or less is concentrating on the same ideas, okay? Also, better understanding of significance of implementation. Now, this type of reason is extremely important, and I will explain why, and I put actually different points. By the way, if you read properly the slides and listen to what I say now, you don't need to go back to the book. I try to abbreviate and collect the most important points from the book, as well as my own understanding and other resources, and I put them in the slide. So of course 90%, around 90% or so from the book. Why? Because it's the textbook we use. I don't want to load you with other resources unless it is needed. For this part, there is not much of a need from other resources. A little bit I added, and I reshaped it by my own words. From time to time I changed the context of the words, or whatever the text needed, I added. Okay, so just a reminder, you don't have to go to the book if you listen to the video properly and read the slides in a good way. Now we get back. The other point, a better understanding of significance of implementation. Why do we need to understand the implementation of a programming language? Now, in order for you to solve any issue comes to you from a programming language, you need to understand how it is implemented. This is number one. Number two, if you understand how the language is implemented, then you will be able to write efficient programs with it. You know its constructs, you know how to use them, you know the control structure very well, how it is implemented. So efficiency, that matters. Okay. More, let's say you are aware of the implementation of a programming language, and once you get a bug or a problem while running, let's say compiling or running a program, then you are the best person to know the solution of this bug or a problem. Okay. One more thing. Now, if you are familiar with the implementation of a programming language, you will know how the computer is actually going to execute it. Okay. Or if you are using different constructs, you will know from these different constructs how the computer reacts to them. And that's also important in programming languages. So imagine all these benefits from just one point here, like the implementation, understanding of the implementation of a language. That is one of the reasons for which actually we study the concepts of programming languages. The fifth reason, better use of languages that are already known. Okay, now I said earlier, if you limit yourself to the languages that you know, most likely you will end up outdated. Okay, but here's the thing. Let's say you are familiar with one language, but familiar with what? Familiar with, let's say, writing codes with loops, with control structures, codes that have exception handling, or classes. How about some unused parts of the language? Okay, and for sure there are a lot of unused. Only with experts or those who are very familiar with programming languages, they use these uncommonly used parts. And do not underestimate them. Why? They may help you solve a problem that you may spend like days and weeks to solve without knowing these unused parts. The concept of programming languages help you to dig these parts, to go to them and check them. Why? It gives you ideas about those, and we will see in next few chapters how actually such an idea or such a course helps you to do so. Okay. The sixth point, overall advancement of computing. Now, as I said, one of the things that encourages programmers from any stream, software engineers or computer engineers or even hobbyists, if they know the concept of programming languages, what do they do? Usually they expand their knowledge by getting to know new programming languages and applying the concepts they learn from their own courses, such concepts of programming languages or programming languages in general, to the new languages that come to existence. So, well, Now let's say if we think about the trends available nowadays in our life, which actually the most popular language, if I ask this question to a class of students, everyone will give me an answer. And if we go to the internet and check which language is the most popular, we will get different answers. Why? Because it depends on the type of the application. Due to that, one of the reasons we need to know even the trends in programming in our modern life, why this trend is going to the direction to, let's say, Java over C#, for example, or vice versa, C# over Java, or Java over Visual Basic. So what is the reason why the trend is going to that direction? Maybe Java is more efficient than C#. I say maybe, okay, we will discuss those later on. But why is it more popular? Sometimes because it is actually free, 100%. It's provided free, 100% from its own developers, and that's why we need to have like an idea about the popularity of the languages through the concept of programming languages. All right. What kind of applications or the domains of programming? So we speak about the concept of programming languages. We need to address what kind of domain we are dealing with. So the domain here refers to the application of which we use the programming language for, or the programming languages for. The early time of computer invention, or the digital actually computer invention, it was between the 1940s and the 1960s. That was actually the core idea of the digital computer we have nowadays, and it was generated or created or actually invented mainly for war reason. At that time, the beginning of Second World War, and things went to chaos between many countries, and they were trying to find the best solution to defeat their own enemies, so they turned to scholars. Scholars of which? Of everything. So back then, the most troublesome calculations they had with math was actually the computation of big, large, actually floating point numbers. They were taking too long for them to compute different mathematical formulas with large floating point numbers. For that, they invented these early digital computers. So it was for scientific application. Of course, for war, yes, but the problem was actually solving a scientific computer problem. So it was a problem where we needed computation ability to solve. It was not normal or possible for human beings to solve it on their own, and that was the basic idea for this invention. At an early time, so we said we need to deal with numbers. So the best fit for numbers in this case, let's speak about two things: data structures. Data structures, the easiest and the most common fit for numerical values, I would say arrays. You guys studied arrays, okay? So for this array, you can just think about just basic plain numerical values stored in them. For sure, in terms of their calculations, whatever the calculation is, arrays are very efficient in this case. And also, how about the control structures? For the control structures, the elementary control structures used back then or needed back then were loops and selections. Selections means whatever you guys studied in algorithms and programming, like if statement or switch statement and those type of selection statements. So these are elementary, they are simple. But what we needed back then, or what it was needed back then, is actually computation ability to allow the computer to deal with numbers. So the core idea, simple implementation of a language that produces computation with large floating point numbers, And for that reason, the first invention, I would say, of a successful, so it's just a successful programming language applied in this concept, was Fortran. Fortran is actually the abbreviation of, sometimes they write it, I personally write it in capital letters. It is the short form of formula translation, and we will discuss it later on when we reach to its part in our discussion, not now, in further chapters. But this Fortran is extremely efficient with numbers and basic mathematical, or I would say scientific mathematical application. The interesting part is Fortran is still being used now, so a lot of people are still using it. Even when I studied my own degree, we studied Fortran back then, and it was really efficient for scientific calculations. Okay, business applications. After the First World War, people started turning to business. Well, we fed up from war, let's just build our country and create our own, let's say, nice environment. So in that case, usually actually between 1950s and 70s, that was the most bright era of early computers. Okay, so for this invention, or for this actually concentration on business, what did they need? They need a language that fits the domain of business. So we don't need scientific calculation. We are not actually oriented towards science and mathematics or physics or anything. No, we are oriented towards business. So what does business need? It needs actually representation of maybe business plan, maybe spreadsheet or anything related to reports, numbers, names, characters, so all these things. And the best fit back then was COBOL. COBOL is a short form of Common Business Oriented Language. Back then was the most common language for such thing. It was in 60s. Actually, it was officially released in a successful version in 60s, and we speak about a really long period compared to our day-to-day. Artificial intelligence is actually a field of which we try to deal with the computer using symbols rather than numbers. We say, like, we are not interested in representing our program or our whatever form that we want to communicate with the computer with in numbers. We don't say we have a mathematical, let's say, operation. Rather, we say usually we have a logical operation. We study this in logic circuits. So for this reason, we need a programming language that helps us applying computations in terms of symbolic representation rather than numbers. So in this case, we don't need numbers. Arrays are not really fit. So what's the best replacement of arrays? You guys are studying data structures now. Linked lists. I'm sure you have studied by now linked lists. So the best fit for changing or for replacing arrays is actually the linked list in terms of symbolic representation. In this case, if you are not dealing with numbers, you can replace arrays by linked lists. What kind of languages will do this for us? We have a language called Lisp. It's list processing. Okay, list processing. This is the full version of the name. It's abbreviated to Lisp. And we have also Prolog. This was the earlier version. This is a bit more advanced, you can say. Programming in logic. I use this language from time to time in discrete mathematics and also in logic circuits. We may write some codes with it. I hope we will get enough time to do so. Okay, and it helps actually for a lot of artificial intelligence applications. Now, of all surprises, one of the very old versions of programming languages, programming in C or C programming actually, is popular for artificial intelligence application now. It's really popular nowadays. A lot of people are using it. And I'll explain the reason, not now, in future, in further chapters. We have also system programming. So what does it mean, system programming? You guys studied about the system in Introduction to Computer Science. System actually is the core where we place in computers, and I'm speaking about computation or computing machines. So what we are referring to by system here is a special software that other software packages for our application, for human being application, rely on, or actually installed on, or they come on top of. They need it as a platform. So this is a system. We can call Windows a system. We can call DOS a system. We can call whatever system that runs our machine a system. So for this, in order for us to program a system or a computer system, what we need first of all, the first characteristic we need is the efficiency. Why? Because these systems run continuously until you shut down the computer. So they have to be efficiently designed. Efficiently designed knowing what? The resources needed for the computer, the time and the memory. So you need to efficiently use the time and the memory of your computer resources in order for you to come up with a good system application. Okay. What kind of languages fit this one? C is one of the best languages. It's extremely efficient when it comes to the level of the machine, and that's why it is widely used even in Android applications. Maybe you've heard of this before. You wonder why Android applications, we may need to write sometimes at the core base, we need to use C because it's efficiently actually realizing system applications near or close to the hardware of the machine or of the computer. Okay, the last domain we have the web software. Nowadays everything is transferring to web. Actually, it's been for a while, but we are going to this direction more and more. So the idea of having web software application or domain dictates that we have a need for programming languages to code them, to create them. For web applications, we have what we call markup language, or the HTML, hypertext markup language. This is one of the most popular. But HTML creates for you a static website. A static, that means with no action, similar to this page now. It doesn't move, it doesn't make any action, you cannot embed a video or whatever. So for that reason, we use what we call scripting. We embed things to a static page to transfer it to a dynamic page, or to make it look as dynamic, a dynamic page. We can use for that PHP or JavaScripting or JavaScript for that case. Also Java is possible. We can use applets to embed them inside an HTML static page. Actually, this is the end of this session. As I said, I try to limit my videos to a shorter period. We will have another part soon enough. Until then, have a good time. Goodbye.